Thank you guys so much for taking the time to join us today for our DevOps webinar. My name is Jen Fuentes, and not only am I awesome, I am one of the IT solution advisors here at CMG. By the end of this presentation, we hope you'll have a clear understanding of the value in automation engineering that CMG can bring to your organization. Today, we intend to give you a crash course on DevOps. This is intended to jumpstart your journey or expand your existing journey into Agile or DevOps using common tools. The focus today is based on many free and open source tool sets, all of which can be used in the cloud. We will cover terminology, technologies, use cases, demonstration, and end with providing you with some resources to take away. With these resources, you can use to explore many cloud-based services, often used to support a CI/CD pipeline. Okay, before we go over the agenda, I'd love to quickly introduce my awesome team on the call. We have Anthony DiDonato. Not only is he the founder of CMG, but he is also one of our principal architects. We've got Tom Wilson, our Senior VP of Pro Services, Zach Thurman, one of our Senior DevOps engineers, and Adam Rubik, one of our DevOps and MLOPS engineers. Yes, we are a bunch of aliens here to control your mind and instill this awesome DevOps content. But in reality, I'm just teasing. I don't know who the heck picked the aliens, but they were picked to have a smooth transition for y'all throughout the presentation, so we know who's presenting. Okay, now let's go over the agenda. I'll briefly discuss the business value of DevOps in your environment. Some of you may not be familiar with DevOps, so I'll quickly cover that. We will review the development workflows, the CI/CD pipelines, discuss technologies in use and the skills required, discuss some use cases for automation. We'll cover some on-prem versus the cloud, and demonstrate help desk ticket automation, web app deployment, the ML model and application deployment. In other words, you're going to see some pretty cool stuff throughout this demo. The business value of DevOps is not difficult to define. However, it is difficult to fit into one slide. Here at CMG, not only do we love automation, but we also use automation for many things. We have long adopted the approach of fail fast, fix forward. We have also adopted the concept of building minimum valuable products and improving over iterations. The improvements are all facilitated by taking a DevOps approach due in part of the business value that it brings. We are able to reduce downtime by having rapid recovery components built into your CI/CD pipelines. We will also talk about and demonstrate much of this terminology later in the webinar. Some of the low-hanging fruit to be had with DevOps include reduced downtime, automating those pesky mundane tasks, reducing shadow IT by delivering faster, repeatable results, and simplified auditing, reporting, and monitoring. There's more business value to be had by leveraging Agile and DevOps principles, but for now, we're just going to focus on the automation. Now let's discuss DevOps, which in my opinion is the science of automation, which is awesome if executed the right way. Effectively, this is infrastructure as code, where we automate all stages of building, staging, testing, and deploying code, and in some cases, configuration changes. DevOps is typically associated with the term CI/CD, also known as continuous integration, continuous deployment, and in some cases, you may see or hear continuous delivery, or by using the Agile methodology. Now, I'll throw this question out to you. Raise your hand if you want to make the work life easier. I should see a lot of hands going up because who doesn't want that, right? The cool thing about DevOps is automation does that for you. Now I'm going to hand it over to Anthony, where he's going to discuss the workflows, CI/CD pipeline, and some of the different technologies in use today.
Yeah, thanks, Jen. Is my audio clear? All right. So
you're good, Anthony.
Okay, thanks. From an overall DevOps and Agile approach, it's been widely adopted by application development and deployment teams. So it makes sense to start off with a development workflow or your software development lifecycle. So typically what you have in that environment is a project management office or a scrum master, line of business or business owner with a team of developers and testers. They go through a process using a workflow, and they usually use the term sprints. Sprints are typically short bursts of time where the team will work on prioritized features, bugs, and enhancements and track those tasks. While they're tracking the tasks, the development team will typically use their development environment, check out a branch or pull tags, and push code back and forth into a source code management platform, which includes obviously issue tracking, pulling and managing the branches, developing or modifying the code, committing the code and pushing it, and then eventually merging it. It's a lot like herding cats. It really depends on how you approach it, but that's the general workflow. So you have your developers producing code. The DevOps team is typically going to push that code into production, and we'll walk through that in a minute when we talk about the CI/CD pipeline. So when you think about DevOps and understanding that's been widely adopted by developers and the folks who deploy the applications, there's so many other use cases for this approach, whether it's building your cloud environment with software-defined networking, provisioning or deprovisioning accounts, devices, things like that. Data engineering, whether you're doing ETL or any kind of MLOPS, audit and compliance. So if you're dealing with auditors or compliance folks on a regular and you need to produce data, it's pretty easy to automate most of those tasks using a CI/CD pipeline. And last but not least, my favorite is the chaos engineering approach. We'll talk about that a little bit later, but it really helps you understand, are you truly fault tolerant? So you can use your CI/CD pipeline to introduce planned or unplanned failures into your environment to see how well you adapt to fault tolerance. Naturally, I haven't listed everything, but this is just food for thought. If you're thinking of DevOps just from a perspective of application deployment, it does that very well. CI/CD pipelines work very well for building, testing, deploying, monitoring applications, but you can use it for a whole lot more. So let's talk about a typical CI/CD pipeline. You have your source code management in a repository. That repository is pulled down from the pipeline. It's cloned typically, not always. From there, it's built and then deployed to a staging environment, maybe a testing environment or additional testing. And then last but not least, deployed to production. There are pipelines that are far more sophisticated than this, but since it's a crash course, I'm just trying to give you a general understanding. At each stage, we can produce artifacts and reports. And what that is the output of the build, the output of the deployment, the output of the testing, and then any monitoring that you're doing on the production environment. With those artifacts, you typically feed back into your issue tracking system or your workflow tracking system for bugs, features, or enhancements. However, if you think about the other use cases I mentioned, naturally this could be any workflow. So from a DevOps and a CI/CD perspective, there are obviously some best practices. Tracking your work assignments will show that as well. Using source code management, using tags, not necessarily branches all the time. We could argue the merits of that recommendation. Automating your builds and configuration changes so that things are no longer done manually. It's much easier to roll forward, roll back, and audit that process than it is to have a human in the loop. Validating and testing, and then using and not being afraid to fail a build by using quality gates. So effectively, if you determine the threshold for failure, you can stop on critical failures during the testing phase and roll back. That way the build will not continue, and whatever was in production stays in production. Naturally, you're going to deploy through CI/CD and then make continuous improvements. You want to avoid monolithic or large scale changes. And then naturally, collaboration, making sure everyone is in the loop. So if you have a solid workflow tracking system, it's very easy for everyone to understand what stage of the workflow you're in. So that's the high level. Let's talk about the technologies that are required to effectively adopt or leverage DevOps. You heard about work management, source code management. We've talked about CI/CD pipeline. You haven't seen it yet, you will. You're going to need to understand containers and repositories. Naturally, you're going to need to understand the concept of infrastructure automation automated infrastructure testing, scripting languages, and any other supporting infrastructure. We're going to cover all these topics individually. So from a work management perspective, you'll hear terms like issue, task, project, epic. These are all methods for managing work in an agile environment. Probably most commonly, or at least my experience has been most commonly with Jira. You also see some issue tracking in GitLab and GitHub. GitLab has more of a issue tracking system than GitHub does, which I'll talk about in a second. And then kicking off all of the agile work efforts, it often comes from your ITSM platform where you've implemented your ITIL standards. So tools like ServiceNow, Avanti Service Manager, even Jira Service Management. One quick tip, Tom Wilson and Jen will be posting on the website a lot of the buzzwords and jargon that we're throwing out here so that you have a definitive set of notes if you want to go back and start to develop and select the tools that you would want to use moving forward. We can give you recommendations on any one of these. From a containers and repositories perspective, Docker, Docker Hub, Kubernetes, and OpenShift. OpenShift is effectively the supported version of Kubernetes versus the open source version. Then you have repositories for Python packages or Node.js or JavaScript packages. One of the reasons this is important to understand is that if you're going to get into DevOps, you're going to use a lot of containers. And those containers rely on images. Whether you use publicly available images or your own custom built images is a decision you have to make based on your risk tolerance. One thing to keep in mind, even though this is not a security focused event, the next one will be, there are a lot of supply chain attacks in open source software. So if you're using Python or Node.js or JavaScript for that matter, and you're using publicly available libraries, there is a lot of malicious and accidental security risk introduced there. So you would want to understand and consider whether you need to build your own or use the public. Next term, source code management. So what is source code management? It's really understanding source code management is a critical skill. While it's not the only technology in use, learning to use Git is vital. So pulling code, pushing code, creating labels, pulling branches, pushing. Now, learning to manage a repository for branches, pull requests, issues, and merges is necessary so that when you have multiple developers all working in concert, you're keeping effective version control and you're not introducing overlapping failure or overlapping security related issues. So when you think of source code management, it's effectively version control with a lot more bells and whistles. So before you start to select tools, and we're going to talk about more tools, it's important to understand that you have a clear grasp of your own requirements. GitHub is probably one of the most prolific and has quite a bit of market share. We actually prefer to use GitLab and Bitbucket and a couple others actually, because there's more features built into it than just source code management. So when you look at your requirements, you want to map them out and see which platform or CI/CD pipeline or workflow management tool is going to meet your needs the best. So if you have significant security requirements, you might want to stay away from one or two platforms. So it's important to do that due diligence. There are a lot of tools that we'll mention here. And again, we can provide recommendations on any, but these are the tools that you're going to need to learn to, you're going to need to invest some time in. Infrastructure automation. If we talk about birthright provisioning, things like that, new employee comes to a company or old employee leaves. You want to be able to automate simple tasks, right? Deploying a Windows platform, a Unix platform, networking devices, or even PCs and things like that, or even jump boxes with COVID today. There are a lot of tools out there to support infrastructure automation. One of my favorites is Ansible. My second favorite is the Salt Project. There are others, Chef and Puppet, as well as PowerShell and Python. If you're familiar with scripting, you'll probably fit in really well with the DevOps culture. If I were to make recommendations on tools, Chef and Puppet are very similar to Ansible with different features and different capabilities. However, they're a little more complex to understand. So if you're jumping in and you want to get started, Ansible is very easy to learn. and I would recommend that. If you haven't checked out the SALT project, which was recently acquired by VMware, I highly recommend that as well. So from an infrastructure testing perspective, naturally Chef, Ansible, Puppet all have those capabilities built into their tool set, but there are some other specialized tools out there. So I mentioned chaos engineering, which is effectively, I wouldn't say it's effectively, it was created by Netflix to introduce failure into their environment to find out if they were resilient. Since then, it has taken off. So if you're starting out to understand fault tolerant testing or even disaster recovery testing, Chaos Monkey is very helpful. I also like Batfish. So if you're going to make a change to your network, you can use Batfish, which is an open source software package that allows you to take copies of your network configurations, introduce a change, and see what the result would be if you're going to introduce a routing failure or a switching failure or a security failure. You can do all that in a simulated and isolated environment based on your current running configurations. Very slick, very cool, and low risk. And naturally, SaltStack has a lot of automated testing for your infrastructure as well. From a CI/CD pipeline software perspective, they also have source code management built into them often, as well as container support. There are a number of tools out there. We've worked with every one of these tools. The predominant for early adopters is often Jenkins. You see Bitbucket and GitLab quite a bit, both in the cloud and on premise with GitHub, Circle CI. Obviously, Amazon has their own pipeline software and capabilities, followed by Azure and Google Cloud. So you'll need to pick one and start there. I can tell you when we get to scripting languages, if you select one that supports YAML, it will be much easier to adopt. If you need more advanced features, you're going to want to get into the Groovy scripting. So from a scripting languages perspective, it's very important to be effective in DevOps to understand Python. That's my preferred weapon of choice. Unix shell commands, Windows PowerShell if you're dealing with Windows environments, Groovy and YAML, which are the languages spoken through the pipeline, which you'll see in our demonstrations in a few minutes. And then other infrastructure. It's very rare that you're going to find a DevOps environment that doesn't have a SIM, where they're storing all of their logs and collecting data, not just for security, but for any operational or audit-related data. Storage is important. Understanding and architecting the amount of storage you need is very important from a cost and a scalability perspective. There's several hosting platforms out there, which are all, I'm sure, very familiar with. You have AWS, Google Cloud Platform, and Azure, as well as others that are not behemoths. And then you have the on-premise approach where you have to understand VMware, Xen Server, Docker, Kubernetes or OpenShift, and last but not least, Hyper-V. I'm not so happy with Hyper-V, so I wouldn't recommend that one. Some quick use cases. This is where we're going to start to introduce and move into the demos. We have some quick use cases, but this is food for thought. If you're looking to get into DevOps, it doesn't have to be just deploying a web-based app with a SQL backend. You can deploy an app, which we will demonstrate, and provide you with a tutorial and full source code with a working pipeline that you can use offline to learn and develop your skill set. You can use it to deploy a workstation integrated with an ITSM request platform, deploy a server, add a route, add a firewall, decommission a firewall, reset a password. We're going to show you a use case there where we're working with ITSM or help desk software to remove the help desk engineer from the equation and have all of that automated using CI/CD. You could resolve printer issues, networking issues, collecting root cause analysis data. All these things can be automated based on a trigger. So if you can collect the logs in your SIM, you can trigger a workflow to go and get that data so that you don't spend hours trying to find out what just happened. We'll also demonstrate how MLOPS or machine learning operations has adopted the DevOps approach as well. So we'll deploy a machine learning model with a front-end API. That demo comes with a full tutorial with source and a working pipeline. Those will be publicly available and posted in the webinar here. And last but not least, automating issue resolution, which is one of our first demos. So moving into the first demo, We're going to do a CI/CD pipeline for automating password resets for the help desk. The use case is pretty simple. We're going to create an automated process that upon ticket creation resets the application credentials for a user without requiring a call to the help desk. And we added additional functionality to allow for approvals by management. So resets should be audited and logged. That's a requirement. And when the task is complete, the CI/CD job closes the ticket, assumes the application does not have a built-in password reset. So user goes to the self-service portal, opens the ticket, triggers a CI/CD job. If it requires approval, there's a separate process. We're going to assume this first workflow does not. It'll connect to the app, authenticate, update the password, notify the user, and log the activity, notifying the user with the new password. If it requires approval, the manager has to manually interact to approve or deny. We built this functionality into the use case because there are certain applications that have privileged access. So we don't want them to be accidentally or maliciously changed. If that's approved, it follows the same workflow, and if not, the ticket is closed and the user is notified that it's been denied. So the pipeline that you'll see here, we're using Bitbucket as a CI/CD pipeline. You'll see multiple pipelines so that you get exposure to more than one. We're using Docker containers. We've integrated with Jira Service Management as our ITSM platform or our ticketing system. It's integrated with Exchange Online, as well as Heroku for application hosting. We used Heroku so that if you wanted to build this on your own, it wouldn't cost you anything. This application we do not provide tutorial and demo on because this is proprietary. We built the application using Flask and Python, so it's full stack, HTML, JavaScript, CSS. Backend is a PostgreSQL database using the Heroku add-on. And as I mentioned in the workflow, we'll be demonstrating automated issue resolution. And with that, I'll turn it over to Adam for demo.
Thanks, Anthony. Let's go ahead and dive into the demo. So first, I really quickly just want to show some of the different screens that you're going to be looking at. So this first one is the web app. We can see we have users and privileged users. Privileged users are just going to be users that require manual approval to have their password reset. So this could be a user with admin or advanced privileges. Then we have the service management side from what the admin is going to see. So all the requests are going to come in here and be logged and manually approved or denied if necessary in here as well. Then we have the service management portal for the actual where the reset requests are going to be submitted. So we have a whole bunch of different requests we can do here, but we're going to be focusing on common requests and then request password reset. Then I have a few emails set up. This is an email where any administrative emails are going to be sent to. And then I have two emails for users, one for a normal user and then one for a privileged user. So with that, let's first just show that these passwords can be used to actually log in. And we can see, hello Dory, you've successfully logged in. The reason I'm also showing passwords here is so it's super easy to see once a password has been updated. So it's just for visibility. So let's go ahead and start and submit a request. First one we're going to do is just for a regular user, and we're going to do that for Dory. And we can see if we refresh, we have some automation running in the background that has changed our request to pending. And if we refresh one more time, we can see our status has been approved. If we look at the admin side of service management, we can see that the request has come in and it's been approved. So no manual input needed for that. And if we go ahead and check the user's email, we can see we have an email here that says hello Dory and we have a new password. So if we just note this password really quickly and we go back to the web app, we can refresh the page and we'll see it update. We can take the password, go back, log in just like we did before, but this time with the new password, and we've logged in all the same. So let's go ahead and do a password reset for a privileged user. So this is going to be the exact same setup. We're going to go ahead and give it a name, type the username that we want to reset, and submit the ticket. If we refresh, we'll see we go into pending. And if we refresh again, this time we're going to see, oh, I did the same user. Let's see. Let's do Nemo this time instead of Dory. So if we refresh, we are in pending. And now we're in awaiting approval. So if we go check the admin side of service management, we'll see here's our request and we're in awaiting approval. So we also got a few emails there. So the admin got sent an email saying, hello, Nemo is requesting a new password. Please check Jira to approve or deny the request. And this link will go straight back to the admin portal that we've already seen. And Nemo also gets a password in their email, or they get an email that says, hello, Nemo, your request must be approved by an admin before your password can be reset. So let's go into the service management. Let's click on this and let's manually approve this password. We go back to the email chain and refresh. We'll see that we have our new password and we'll just note what that is. Go back to the web app. We will refresh and it's been updated. So we can go ahead and take this and log in. And we've successfully logged in. So now let's look at some examples of password requests being denied. And first we'll do a regular user. And so here we can see we have Dory and Bruce. So we're going to go ahead and make a user and a request for a user that doesn't exist because that will obviously be denied. And we'll go ahead and give this a name and we'll request the user with the username Adam to have their password reset, which we know won't work. So if we refresh this, we are in pending. And this time, instead of being approved, we are denied. If we go into the service management admin side of things, we can see the ticket has come in, it has been denied, and the admin received an email saying, hello, Adam requested a new password and it was denied. And then just, again, for more information, check the board. So the last one we can do, if we go back to the web app and we refresh, nothing is going to change because that user never existed. So the last one we're going to do is this time we're going to, again, submit a ticket for a privileged user. And instead of approving it, we're going to manually deny it. So again, we'll do that for Nemo. We will head back here. And as we can see, if we refresh the ticket, we are in awaiting approval. We can see that pop up here. And this time we'll just take it and we will manually deny this request. And if we go back and look at the ticket, we can see it has been changed to denied. And if we refresh the email, we can see, hello Nemo, your request has been denied. And so if we go back to the web app and refresh, this password hasn't changed and it still works if we want to log in. So that's the demo side of things done. Before I go back to the slides, I quickly just want to show some stuff in Bitbucket. So I have some of my source code out here. And we have a Bitbucket pipeline, which automatically builds the app in Heroku. So if I look at the pipeline, you can see its rate of success. And so I just pushed an update about an hour ago, and we can see that it's successfully built. And so as soon as any changes are made in the source code and those changes are pushed here, the pipeline kicks off and it starts building a new version in Heroku. And we can see what that pipeline does by this YAML file. It's pretty simple. Basically, I just install any requirements for the project, and then I just push out to the Heroku app. And if we check in on Heroku, here's an example of the build. So we can see it's all really simple and super easy, and it's all automated in the background. Let's quickly go back into the slides. So what am I using and why? Bitbucket, we just talked about it. It integrates super well with Jira, and it's super easy to use. Also later in the presentation, we're going to be doing some demos with GitLab, so we just wanted to give a different solution and show that. Also, Heroku, like Anthony had already gone over, Heroku's great. It's free, and it's super easy for deploying quick web apps. And then for the code side of things, I'm using Python, Flask, and PostgreSQL. Again, it's just super easy to make very simple web apps with this, with Python and Flask, and so that's the reasoning for that. So with that, thank you, and I'm going to throw it back to Anthony.
Hey, thanks, Adam. Great demo. That might have went a little fast for some of you. Zach is going to go through a demo of a pipeline that we will share with you so that you can look at the pipeline line by line, as well as the environment variables, and understanding all of the nodes in the pipeline. So let's set up the next, which will be available to you publicly so that you can go and tinker around as you like. This is a typical web-based application deployment using a CI/CD pipeline. We are going to use GitLab coupled with Docker to build 3 environments: a staging, a testing, and a production environment. Again, we're using Heroku with a Node.js application with a backend database hosted on MongoDB Atlas clusters. And eventually we'll be deploying the OWASP Node-Goat application. So we have GitLab CI/CD pipeline with Docker, Heroku, Node.js, MongoDB Atlas, which is an online database platform, and the OWASP Node-Goat application. With that, I'll turn it over to Zach.
All right, thanks, Anthony.
I was going to say, or not.
Sorry, mute button was getting away from me. All right, so as we stated previously, we're using MongoDB, Heroku, and GitLab for this demo. To start, we'll take a look at the MongoDB setup, followed by Heroku, which is here, and then finally GitLab. So for this, GitLab repository, as Anthony mentioned, it is publicly available. This is pretty much just a clone of the original Node-Goat GitHub repo, which can be found in the README down here. We just added a few things to this repo, such as the database setup, which sets up the database for us, the YML file, which is our pipeline, and then a detailed README that can be found at the very bottom here that gives you step-by-step instructions on setting this up yourself in your own environment. So with that out of the way, we'll go ahead and go through a high-level overview of the setup and then take a look at the finished product. So we'll go back over to MongoDB after we start the pipeline, and we'll take a look at how that's set up. So we'll kick off the pipeline here, get this going, and then when we go through all the setup, we should be able to come back and at least every test should be done to take a look at. So while that's running, we'll go ahead and take a look at MongoDB, Heroku, and GitLab. So in MongoDB, when you initially create your account, it'll have you create a organization and a project. This is what we have here, just a simple project, nothing too advanced going on here. We just have a cluster created here, some database access rules, or user, and some network access rules. So in our cluster, which is hosted out on AWS, there's a couple different platforms that you can choose when you set up your cluster, but we just have the AWS selected here. And in our cluster, we have collections, which are essentially your database and all the data that's going to be used for the application. You can see there's nothing in here currently, but as I said previously, that's what that database setup folder was for. We have created a custom Python script to connect to the MongoDB API that will actually come out here, create the database that we need, create the collections, and populate it with all the data that the Node-Goat application needs. This allows for you to be able to make a easier setup in your own environment, so you don't have to come in here and populate the data yourself. So if we go back to the project, the only other thing that you need from your cluster is the connection strings, which can be found under the connect button. This is essentially how your application and that Python script is going to connect to your MongoDB instance to actually set it up and or connect to it. So the connection strings that you need are either Node.js or Python. They actually produce the same string. So for Node.js, you need 212 or later. And then for Python, you need 34 or later. These strings do need a few things modified with them. One being the password, which is found here, and the other is the database. That can all be found in the description down below as well. It does note that those things need to be replaced with the required information for your environment. The password is just whatever you configure in your database access node over there, which is we'll take a look at in a sec. And then the database for Node-Goat is just Node-Goat. So that's what we have hard coded in the Python script. If you do anything other than Node-Goat, it will not work. You could obviously modify the Python script if you clone the repo, but if you keep it simple, I would just go with Node-Goat. So heading over to database access, this is how the Heroku application actually connects to MongoDB. So we have a service account created here. We give it a password, and then we change the rights that it's given. So by default, when you create your user account has read-write access to MongoDB, we actually had to up it to this admin rights, as you can see here. The reason for this is so that it has actually access to use the MongoDB API to actually connect out here and create our database in our cluster. Moving on from that, we have our network access. So this is the access rules that we're going to allow for what IPs are able to access our MongoDB instance. You can see that we're allowing all IPs currently, which I would generally not recommend, but for this instance, it's just a lab setup, so I'm not really that concerned. The user account has a pretty strong password on it, so I don't think anyone will be abusing my database. And if we go back to the database and we go into browse collections, we should see database in here with the collections that we need. So there we go. So the Python script did what we wanted it to. It connected out to the MongoDB API, created a database in our cluster with all the collections that we need. So the main one that we really need is the user here with the account name and the password that we're going to use to actually log into the no-code application in a little bit. So with that, we'll go over to Heroku and take a look at how that's set up. So you can see here, I have 4 applications set up in Heroku, 3 of which are used for this setup and 1 of which will be used in a later demo. So the 3 here are the Node-Goat, dev, test, and production applications. So we'll just take a look at one of these for now because they're all set up the same exact way. The only thing that you really need to change in the Heroku setup for your app is under settings. There is configuration variables that need to be populated, really just one, the MongoDB URI, and it does need to be MongoDB URI. It can't be anything other than that. It is hard-coded in the Mongo or in the no-go application for this specific string here. So you have to give it the connection string that we copied from MongoDB and just replace the, like I said, the password in the database that you used previously. The only other thing that you need in Heroku from here is the account settings and your API key. So your API key gets created when you create your Heroku account. You just need to click reveal to actually see the password there. So now we've gone over Heroku and how that's set up. We just need to go over to GitLab and review how this pipeline is configured. So if we go out here, I'll just quickly take a look at the DB setup folder here, and we'll see how this is configured. So we have just Python script and then requirements.txt file. The requirements.txt file will install any requirements needed for the Python script, and then the Python script will actually go out to MongoDB, create the database and the collections that we need. I'm not going to take a look at that. You can always clone this repository and take a look at that yourself if you wanted to do so. We'll post a link for the GitHub repo or the GitLab repo that's public in a little bit for you to consume. So looking at the pipeline here, YML file, you can see that we have 4 stages. We have a database setup stage, a dev, test, and production stage. So each stage runs in the order that they're presented. This pipeline makes use of Docker images to run the underlying code. Python and Ruby are the 2 being used. The first stage is the database setup stage, which runs the custom script that we created to interact with and set up the MongoDB needed for the Node-Go application. So you can see here it runs the requirements.txt file and then it runs the Python script. So this stage goes through the creation and allocation of the database and the collections using the Python Docker image and MongoDB API. The next 3 stages, dev, test, and production, run the exact same code, but on different Heroku apps, as noted by the environment variables here. So we have Heroku app dev, app test, and app production. These stages will use the DLP application, which is a Travis CI developed application used for deploying code or packages to various service providers, such as Heroku, like we're doing today. Travis CI, if you're unfamiliar, is just another DevOps continuous integration platform, much like GitLab, Jenkins, and so forth. This is all running on Ruby Docker image deployed to Heroku using environment variables that we have defined in the app name and Heroku API key. So this API key that we saw in Heroku is used to actually connect to Heroku, and then the app name is used to determine what app needs to deploy to. SDLP application that's developed by Travis CI makes it extremely easy to do so. So taking a look at the environment variables now to see how those correlate with what we have configured there. We'll go into the CI/CD under settings and expand variables. And we can see here that we have 6 variables configured: the Heroku API key, the app dev, test, and production, like you saw in the pipeline file there. Those just correlate. The API key correlates with the API key in the Heroku. the app dev test and production correlate to the names that you have configured for your application in here. So CMG no-go dev would be our dev variable. The MongoDB URI is the same URI that you use in the Heroku application in the settings config vars. And then the no-go admin pass is the password that we want to be able to use to log into the no-go application. So that's actually used in the Python script to populate in the database what the password is going to be, so that you can use any password that you want to log into that application. You don't have to use a hard-coded password at all. So if we take a look at the finished product here, if we go to our pipeline, we should have at least dev done at this point. Maybe test. Okay, so we'll take a look at test. And we'll connect up to the application here. In GitLab, it does have a pretty nice display here. It puts out the Heroku URL that you can use to access your application. So we'll just click on that and we'll sign in with the admin account that we had configured there in the database. And we'll see that we can log in successfully and use the no-go application however we want. So that password that I just used to input to that login page there was what was populated in that environment variable, and that gets populated in the MongoDB database, so we can see that all this is correlated and connecting and working as expected. So that's how you would set up Node-Goat from GitLab using Heroku and MongoDB. So I'll go back to some slides and continue with the webinar. All right, so to recap the setup, we're using the free version of GitLab, Heroku, and MongoDB. GitLab is used for automation and source code management, but there are also a wide range of other uses that weren't covered in this demo that GitLab offers. Heroku is the deployment platform, hosting our Docker images, running the Node-Goat application. We're using Python and Ruby Docker images for this setup. And then MongoDB hosts our Node-Goat database required for the application to function. All right, there are a few resources at your disposal for this demo, including a working CI/CD pipeline, a public GitLab repo that you can clone and run in your own environment, the link for which should be in the chat momentarily. There's also source code for the Node-Goat application, as well as custom Python script that we created to populate the MongoDB database. And then lastly, there's a README that has a full walkthrough of the setup with images to guide you in your own configuration. So with that, I'll pass it back over to Anthony.
Yeah, thanks, Zach. Great work. Okay, so this is not a presentation on machine learning or natural language processing, but we're going to do a quick overview of how this integrates and why it's relative to DevOps and CI/CD pipelines. So we're going to talk about building a model, taking a data set, training a model, saving that model, and then deploying it with a front end that allows it to have a user interface for users to interact with the model. When you think of machine learning models, just think of applications. So with that being said, just set up Zach's demo a little bit here. If you're not familiar with MLOPS, it is the interaction or intersection of machine learning, data engineering, and DevOps. That's a very simplistic way to describe it. So I thought I'd share with you with an image from NVIDIA that outlines a similar or typical pipeline. You'll see that a lot of the work that needs to be done is on the data side. So as I mentioned early on in the use cases, you could use DevOps and CI/CD pipelines for data prep, ETL, all kinds of things. So collecting your data, ingesting it, analyzing it, labeling it. And labeling is basically saying maybe this movie review is a negative review, or this restaurant review is a positive review. You're labeling it as positive or negative. Then you're going to go through and validate that the data is intact, prep it, and then send it to your model for training. And I'm going to demonstrate some of this on a very simplistic kind of hello world style machine learning model. We'll go through and evaluate that model for accuracy. Then we'll validate that and then deploy that. So that will be demonstrated by Zach. But before he does that, I'll review some of the components that we're showing. Keep in mind that this initial repository was based on Majid Khan's deploying ML models with Flask. We've cloned that repo and modified it significantly so that it's easier to use if you're just getting started. So this environment is a working GitLab CI/CD pipeline using Docker containers, Heroku again for application hosting, Gunicorn or Gunicorn, however you want to pronounce it, using Flask and Python, which does give you HTML and JavaScript exposure. It's very insignificant, it's not a lot. From a machine learning perspective, we'll be using scikit-learn and pandas. Matplotlib and NumPy are really more for exploratory. And the simple model will predict salary based on input. So before I hand it over to Zach, just want to give you a quick overview of how machine learning works. So here we're starting with the data set, and the data set will pop up here in a second. Of course not. I think it just crashed. Okay, maybe I won't give you a quick demo. Okay, there you go. This is the data set, and what it is experience, test scores, interview scores, and a predicted salary based on those. So I'll explain how this works from a math perspective in a moment, but you have a CSV file, Excel style format. You have 0 experience, an 8 on your test score, a 9 on your interview score. You would get a $50,000 salary. So the whole point of this model is to take this data set, train the model to determine what the salary would be. The second part is taking that data set and training it as a model. So here, it's pretty simple. This is Python. We're importing our Python libraries, which in this case, we're using pandas, pickle, and scikit-learn with a linear regression model. We're taking the data set as the CSV. We're returning that data set. We're setting the X value, which I'll explain in a minute, which is effectively all rows and the first 4 columns or 3 columns. Then we're setting the value of Y, which I'll also explain in a moment. And the value of Y is all rows here with this colon, and only the last column, which if you recall, that was the salary. So we're using a typical f of x function. So Y, the output or the prediction, is equal to the function of the data provided, input. So the function of x. Typically you would split your data set. This record set has only 10 records. So we're not going to split anything. We're just going to use it for demonstration purposes. So our model will be based on linear regression. So we instantiate that object. Then we fit or train that model. So fit is the same as train. We use X and Y. So basically we're going to tell this machine learning algorithm that we want to train on the values of X and Y. If you don't understand machine learning, I can give you my 30-second version of what it is. It's advanced geometry. So after that, we're going to go and predict an accuracy score based on the training. We're going to dump the model to a disk, and then we're going to test that we can load that model and make a prediction. And in the prediction, we're going to present a 2-dimensional array, which basically says, this was your experience, this was your interview score, and this was your test score. And then last but not least, we'll exit out of there. If I were to run this model, this is more for demonstration purposes. Actually, I'm going to run it in. Here you go. You can see that it gets an accuracy score of 93% based on predictions. And if we were to look at the data, this is our overall data set. This is the values of X, which is experience, test score, and interview score. Y is the predicted salary. And that's pretty much all there is to it. So if you go back and think about machine learning, it really is pretty simple stuff. Building the model was easy, but how do you build it and then deploy it? Zach's going to go through that process now that you know what he's deploying. So Zach, back to you.
All right, thanks again, Anthony. Get my screen up here. All right, so for this demo, we're only going to be using Heroku and GitLab. There's no backend database that we need for this setup. So GitLab is the repo that we're going to be using. It's publicly available, again, like the no-code application. It has a full README that has step-by-step process with images that you can use to set this up in your own environment if you wish to do so. We have taken the GitHub repo, like Anthony mentioned, from this GitHub link here that you can always check out the original repository if you'd like to. We added just a few things like the pipeline file for the GitLab process, the proc file for deploying the web app through Unicorn, and then a requirements.txt file to install all the requirements needed for these Python scripts. All right, so let's take a look at Heroku first, since there's really not a whole lot to look in here. You really just need to create your app for Heroku and give it a name, and then use that name in an environment variable in GitLab. This setup is very simple compared to no-goat. There's no configurations needed in your settings. It'll populate the build packs for you. And you can see here, it's just using Python for this one. So all you need to do is come out here, create a Heroku app, and then use that name in GitLab. And then you just need your API key from your account settings as well. So going back over to GitLab, we'll take a look at the pipeline, how this actually works for deploying a machine learning model. So looking at this pipeline, you can see that we have just one stage here, the deploy stage. The first step in this pipeline that is going to run is the before script step. That's under this heading here. So all this code will run before this script heading will run. What this is doing is installing some prerequisites for the model.py file, and then actually running the model.py file, which Anthony had just showed you. This model will export a PKL or pickle file, which can be imported into the app.py script for actually making the predictions. Once that step is done, it will deploy the prepared application to Heroku, just as we saw in the no-go demo. It uses the Python Docker image to run DLP tool, which ultimately allows us to deploy to Heroku, as we saw in the previous demo as well. So you may notice that there's a skip cleanup argument that you may not have seen in the previous demo. The reason for this is it's preventing DLP from wiping changes that were made to the repository and using the repository plus any changes that were made prior to the command. We need this argument to prevent the pickle file that gets output from being wiped out on deployment. So without this argument here, since the repository is getting a new file, which is that pickle file, since it's not in the repository to begin with, when this gets deployed to Heroku, it will essentially wipe that change out. So the skip cleanup will skip that step and deploy that pickle file with all the other files for it. So looking at the final product, since Anthony's already gone over the model.py file, I guess I could take a look at the app.py file just to show you how that's set up. So what this is doing is it's a basic Flask app. It has a couple routes that we can go to. The base route is the one that we're going to be looking at, which loads the index.html file. And the predict method is just used for actually making the prediction, outputting the contents for the prediction. And then you can see in here that it's taking the pickle file in for the actual predictions. So that's the trained model that was output from the model.py file. And like I said, in the environment variables, there's not really a whole lot to configure. It's just the app name for Heroku and the API key. So you just need two variables out here to get all this working. Much more simple for this setup. We'll take a look at the pipeline and take a look at the finished product. This one I kicked off before going through here because this does not need a whole lot of explanation. So just want to make sure this finished before we got in here. So this is the HTML page that we get presented with. We can put in some sample data in here and we'll see what predicted salary it puts out. So we'll put in 6 years of experience, test score of 8, and interview score of 10. And you can see our salary would be 71,000. Then we could put in another random bit of information and it should output a different value for us. And again, these predictions are all being done from the pickle file that got exported when we ran that model.py file. All right, so back over to the PowerPoint here. So that is how you deploy a machine learning model with GitLab and Heroku. So to recap this machine learning setup, we're using the free version of GitLab and Heroku. One thing I do want to note about the free version of Heroku is that if you do set up both of these demos, the Node Goat and machine learning demo in your own environment, and you try to deploy both of them at the same time through the GitLab pipelines, one of them is going to fail because you only have one runner that is working on Heroku with the free version. So you can only deploy one at a time. So you'll just have to run each of them separately if you wish to do that. So just like the previous demo, GitLab is used for the automation and source code management. Heroku is the deployment platform hosting our Docker image, running the machine learning application. We're just using Python for this configuration. And then for the app itself, Gunicorn is used along with Flask to deliver the web app. The machine learning library is used for the actual prediction and training of the model, includes scikit-learn, pandas, numpy, and matplotlib. And then again, there are multiple resources available to you with this demo, including the CI/CD pipeline, the GitLab repo, which should be in the link for which should be in the chat momentarily, the source code for the machine learning application, as well as some minor changes that we made for this configuration, and then the README that has the full walkthrough of the setup with images to guide you in your own configuration. So with that, I'll pass it back over to Anthony.
All right, thanks, Zach. Okay, I'm not clicking too good there. Well, that's really it for our webinar. We wanted to give you a crash course with takeaways. There's one other takeaway that we did not show, which is a summary document of all of the jargon, buzzwords, and technology we mentioned. You can take the two public Git repositories with the README and start your own journey down the path of deploying web-based apps or machine learning models. There's not much source code in there to learn. So if you're just trying to get in there and poke around a little bit, this is going to be a great opportunity. I'm going to turn it over to Tom to give you a little bit of background on CMG and our services. And then I think last but not least, Jen has some survey and giveaway stuff.
Hey, thanks, Anthony. So hopefully you guys enjoyed the demos and got to see a bit about that. So make sure my screen's sharing okay.
You're good.
Good. So we wanted to take just a few minutes to introduce ourselves to you. If you missed the earlier introduction, my name is Tom Wilson. I actually oversee the professional services for CMG. As CMG is likely new to most of you, we wanted to give you a very brief introduction to who we are. And by very brief, I mean 2 minutes. So I promise not to take a lot of your time. At CMG, our focus is to find and build IT automation and integration experts who are day one ready to deliver IT automation and integration services and solutions. At CMG, we offer services in 3 core practice areas. I think you've seen some of those today. DevOps and DevSecOps is our first area. Second is machine learning and natural language processing. And third is cloud architecture and integration. It's our goal to be your go-to partner for IT automation and integration services and resources. As you'll see, our service offerings range from contract to hire to staff augmentation, managed services to custom projects and solutions. When you need a resource for DevOps, DevSecOps, machine learning, NLP, or cloud architecture and integration, whether it's your goal to find a full-time employee or to fulfill a need for consulting or contracting resources, we want you to think of us, to think of CMG. You can find more information about us, about CMG, on our website at careermentorgroup.com. There you'll find who we are, what makes us different, our service offerings, and our blog. You can sign up for our monthly newsletter on industry trends in these areas. You can find previous webinars and sign up for future webinars. You can even schedule a meeting with us just to discuss possible ideas you have and challenges you may face. We'd also love for you to follow CMG on LinkedIn and connect to us individually on LinkedIn as well. And I know that Adam posted our links there inside the chat if you're looking for those. And for those of you who enjoy the Twitterverse and a good tweet every now and then, you can follow us on Twitter as well. And with that, let me hand it back over to Jen.
Okay, cool. Thanks, Tom. All right, guys, if you enjoyed the content that you saw today, be on the lookout for upcoming webinars that we have. They're crash course webinars, just like what you saw today. The upcoming webinar that we have is going to focus on DevSecOps, where we integrate security into the pipeline. That's going to be August 12th. I've already created a LinkedIn event for that, but you can also register on our website under our events page. We have an artificial intelligence and machine learning on September 9th, and the last webinar in this series will be the artificial intelligence and machine learning for cybersecurity, which is going to be really cool. I'm excited for that one.